Hello, this is Coach Manbauer, and we are on section 1.11 for AP Pre-Calculus. This is just part 2, 1.11, just focusing only on the binomial theorem, so this won't take us too long. So before we talk about the binomial theorem, I want to show you a pattern that's actually on the screen right now, which is something called Pascal's triangle, which we use for the binomial theorem. Now, the binomial theorem, it can look very technical with permutations, and so I'm not going to show you that version of the binomial theorem. I'm just going to show you the version that uses Pascal's triangle, which is a fun little pattern, as you can see below. So I'll draw this pattern out for you to kind of see where this comes from. It's like a little pyramid. The top of the pyramid is a 1. And then the next step of the pyramid is a 1 and a 1. And then from there, we always put 1s on the outside, and we add the numbers in the middle here. So the next one's going to be 1 on the outside. And then if you add the two numbers up, 1 plus 1, I'm going to put a 2 right between it. So for the next row, I got 1 and 1. I don't know why there you go, 1 and 1. And then add the number between 1 and 2, we're going to get 3. Add the number between, we get 3. And so on and so forth. And you can see that with the Pascal's triangle that's already on your screen for you. Okay, so that's the first part. The second part for binomial theorem is really, we're going to focus in on the fourth one for right now. So if you look, a plus b all to the fourth, this is what it does for us. It uses the fourth slot. So if this is slot number 1 right here, 2, 3, and 4, if you notice that the second number is 4, so that's why I call it the fourth slot of this. It's going to use the pattern of the coefficients. It's going to use these coefficients. 1, 4, see how those match up? 6, matches up with the triangle, 4, and 1. What a fun little pattern that is. Okay, and all the a terms start to the fourth and they decrease. So I have a to the fourth right here. A to the third decreases a squared, a to the first, and a to the 0 is our last one. We're just not going to look at it because a to the 0 is just 1. And the b's start at 0, which is the second term, and they increase all the way through. So you can kind of dissect that just by using the fourth. And the same is true for if we did a plus b to the third. We just don't want to show you every single one because it can get kind of jumbled up there with mass amount of information. So that is us expanding using the binomial theorem. So let's just really get to a problem here. And I'll start this one fresh, draw your own Pascal's triangle. So to expand this, which by the way, I think this is super useful. This is a lost art. I am super excited that this is in AP Pre-Calc. I love the binomial theorem. It helps us expand. Instead of having to write this out as x plus 2, don't write this down, please. Do not write this down. X plus 2, x plus 2, x plus 2. So instead of having to distribute x plus 2 times x plus 2 to get x squared plus 4x plus 4 and distribute that again, that's a lot of work. So we do not want to do that. Instead, we'll use the binomial theorem. Okay? So, all right, don't want to expand. Okay, so the binomial theorem is this. Let's go look at Pascal's triangle until we get our second numbers of 4. So 1, 1, 2, 1, 1, 3, 3, 1, and 1, 4, 6, 4, 1. So this is the row that we're going to use. Okay, it's the fourth power row. So here we go. So I'm just going to rewrite the problem if you're okay with that. So I'm going to put a 1 in front. So it's 1 times x to the fourth times 2 to the 0. Don't really care about that. Plus the coefficient is now 4 for the second term. X to the third times 2 to the first. I'll just write that down so you have it. Plus 6x squared times 2 squared, because the 2's are increasing in power, the x's are decreasing. Plus 4, that's my next coefficient, x to the first, 2 cubed. Plus 1 times 2 to the fourth. That's a totally awesome answer. Let's go ahead and just make this look nice and clean and pretty. We're going to get x to the fourth plus 4 times 2 is 8, 8x to the third, plus 6 times 2 squared. 2 squared is 4, so 6 times 4 is 24, x squared, plus 4 times 2 cubed. 2 cubed is 2 times 2 times 2, which is 8, so we're going to get 32. X plus 2 times 2 times 2 times 2 is 16, and that is our full expansion of the bad boy right there. Okay, super simple. The only thing that you can get a little tripped up on is be careful if there's a minus sign in the middle. That means that my second term is negative. That is the only difference of the binomial theorem. Other than that, it follows through with this right here. And also be careful if the coefficient in the front is not a 1, then we need to play around with that. But I have a feeling that our next example will cover that. Yes, it does. It covers both things right here. So here's our next example. And this is to the third, which is nice. A little bit less work here. So if I'm looking at Pascal's triangle, it's going to be this row right here, the 1, 3, 3, 1. Okay. So let's go ahead and expand this. So this is going to also equal 1 times, I'm going to put this in a parentheses, 2x all cubed, negative 3, and that b terms of negative 3. I'll write that down. So a is 2x, b is negative 3. Hello, there we go. B is negative 3. This is plus 3 times 2x all being squared, and this is negative 3 to the first, plus 3 times 2x to the first, negative 3 squared, plus there's no more 2x's, and we're going to get 1 times negative 3 to the third. Okay, so just got to be careful here. We got to have to make sure we distribute the power, I guess you could say it like that. So this is going to be 2 cubed and x cubed, plus 3 times 2 squared x squared times negative 3, plus 3 times 2x, and then negative 3 squared is 9, so times 9, and then plus negative 3 squared is negative 27. I just did that extra step for you in your notes. If you're sufficient to go from the first step to my answer, which is my next step right here, totally fine by me. 2 cubed is 8, so we got 8x cubed. This is going to turn 3 times 2 squared, which is 4. That gives me 12 times negative 3 is negative 36. X squared plus 3 times 2, which is 6 times 9, which is 54. And then minus, that's an x, minus 27. And that is going to wrap up our video here. Do not forget to like and subscribe.